Today we're going to focus on slope and rate of change. So we're going to find rate of change using tables, we're going to find slope given 2 points, and we're going to learn how they're similar. Okay, so we have 2 new vocab words today. We have rate of change, which is your first one, and what's important is a ratio, okay? Underline it, highlight it, that's the important part. It's a ratio that describes how one quantity changes with respect to another quantity. And usually with rate of change, we see this represented in tables, okay? Tables. Okay. Now the other vocab word, of course, is slope. And slope and rate of change are the same thing, okay? Slope is just when the change in the y-coordinate with respect to the change in the x-coordinate. And we see that represented on the coordinate plane, of course, okay? So the y-coordinate with respect to the change in the x-coordinate. Do y'all remember from before slope being rise over run? Yeah. Do you remember hearing that, right? Yeah. Just think about if you were to now don't do it, but if you were to get up and run out of this classroom right now, you would first have to get out of your seat, right? Rise and then run. So slope is the same way, okay? So first we're going to start off with some examples of rate of change. Like I said, this is usually represented in tables, which is what you see right here. Okay, so when we start these problems, let's see if my airliner is going to work back here. Oh, there we go. There we go. Okay, so we do change. Now guys, I'm telling you, my handwriting is going to be really bad on this first one. Change in y, okay, all over change in x. That's your rise over run, remember? Woo! I promise I'll get better. Okay. So, with the rate of change, our first step is we're going to pick 2 points from the table that's given, okay? It doesn't matter which 2 points because it's all part of the same system. It's part of the same problem. But the idea, of course, is to stay consistent. Okay, so if you pick one y, of course you have to use its x. Okay? So change in y. What points do you guys want to use? 2. The first one? Yeah. Okay, and what other one? 6. The 6? Okay, so you want to do, so we do change in y first, okay? And I'm going to pick that 28 to go first so we can have positive numbers, okay? So, right down here. So we have 2, no, I'm just going up here, just kidding. I don't want my handwriting to be too awful up here. Okay. So, you want to use this point, right? And this last one? That's what you all told me? Okay, so what are the y values, the distance or the time?
The distance.
The distance, okay, so my first distance point is 228, okay? Minus, because we're talking about change. What's my other y value?
76.
76, good. Over, now the 228 was paired with what x value? The 6, right, this is where we have to be careful. This is what I mean by being consistent, right? It was 6 and then 228 was the pair, okay. And 76 was paired with what x? 2, okay. So from here, it's just computation, right? We have to do 228 minus 76. Can anyone help me out with that? Get your calculators out. 228 minus 76.
152.
152. Over 6 minus 2 is? 4. And 152 divided by 4 is? 38. Good. Okay. So we got 38 as the rate of change. But all of these problems have a context, right? And this problem we're talking about driving time. So when we find our rate of change, we have to relate it back to the problem, okay? So y was on top, right? And y was talking about the distance distance was in miles, okay? So I'm gonna put miles per, okay? Now the time driving was in hours, okay? So we have 38 miles per hour. Now if I want to write that as a sentence, I could just say, it takes 1 hour to drive 38 miles. Does that make sense? Yeah. So what's important about this is being able to not only find the rate of change, but of course relate it back to what we're talking about. All right, so now we have another rate of change problem. You have a reminder on the side that says to remember that slope and rate of change mean the same thing, right? We're talking about change in one quantity with respect to another. So now we are talking about another traveling problem. We're talking about minutes and miles. So remind me, guys. Let's see if this is going to work better now. Maybe, maybe not. Nope. Okay. Rate of change is the change in what? Change in X or Y in the numerator? Y. Good. Over the change in X. Good. Okay. What 2 points would you like to use from this table? Okay. Do you want to use the second one, or what other one? The bottom one?
Yeah.
Okay. That's fine with me. Remember, we can pick any 2 points as long as we stay consistent, because they're all part of the same system, same function. Okay? Now, once again, I'm going to pick the bigger y value first, just so I can deal with positive numbers. They're a little easier on us. Okay? So my first y value, of course, is the 28.0, if you want to write that, minus. What's my other y value? 9.8, good. Over.
20.
Good, remember we're staying consistent. The 20 was paired with the 28. Minus
7.
7. Good job. All right, let's solve this. 28 minus 9.8.
18.2.
Thank you. 18.2 over. Good. Can someone actually divide that for me? What's 18.2 divided by 13? I'm sorry? 9.4? No, 1.4. So 9.4 doesn't make sense. 1.4. Okay. So we got 1.4, and that's great, but now we need to say what that means, okay? So, my change in y, what was I talking about with y? Distance, and what was distance measured in?
Miles.
Miles, good. Miles over
Time.
time, and time was measured in minutes. Okay. Now remember, this little fraction bar right here means per, okay? Like translate that to a word. So we're at miles per minute. If I were to transform that into a sentence, what could I say?
Takes a minute, 40 seconds to 12, or what is 1.4?
So 1.4 is attached with the miles,
Gotcha.
right?
All right.
This is really 1.4 if you need to write it over 1,
Gotcha.
right? So now do you know how to put that into a sentence?
It takes 1 minute to travel 1.4 miles.
Sweet. This is, did everyone hear him?
No.
He said it takes 1 minute to drive 1.4 miles. Does everyone see how we got that?
Yeah.
Right? It definitely helps, I think, if you put the units really fine on their own. Yeah.
Say if I pick this one, I have to pick this one.
So you can pick any two. You could pick these two, these two, these two. Just as long as you're consistent.
We can get the same answers.
Yes, you'll get the same answer because it's a part of the same system, same function.
Okay.
Okay?
Okay.
Okay, so you picked these 2 points. You did 48 minus 9 over 4 minus 1. This line from the last line. It's negative, right? We're not increasing this time. This time we're decreasing left to right. You all see that? So immediately I know my slope. Is it going to be positive or negative?
Negative.
Negative. Negative slope. Okay, so that means I'm gonna start with my point kind of above, right? The negative slope. So rise over run. Do I need to run up or down to get to the other point? Down. How many spots? We have 1, 2, 3, 4, 5. Good. So I'm going down 5, over. How many do I need to run? 3. 1, 2, 3.
Don't forget the negative sign.
And the negative sign. Good job. Yep. Negative sign because we have a negative slope. I actually looked it up why we use M because it seems kind of silly, right? Like why don't we use S? Well, we use S for other things in math, and no one really knows why we use M. There's like a lot of myths behind it, but we just have M. M for math, yeah. One of the myths is like it means to, like the word to climb in French starts with an M, but that might just be a correlation. We don't know. Okay. All right. So tell me, let's plug and chug here. What's Y2?
3. Or Y2 is.
Y2 is 5, yep, just so we're all on the same page. Minus Y1 is 2, good. Over, what's X2? 5. Minus negative 3, be careful there, it's a double negatives. What happens with those double negatives?
Positive.
Positive, good. So up top, 5 minus 2 is? 3, good. Over, 5 plus 3 is?
8.
So 3/8. So without graphing this line and knowing my slope is positive, how would my line kind of look? What do you think? Just describe it to me. Show me with your hand.
3/8.
Just know, yeah, right? We have an increasing line.
Oh, I thought you
And we don't even have to graph it to know that, right? Because we know we have a positive slope. Okay? All right, someone walk me through this one. Y2 minus Y1 would be what minus what? Good. What's X2 minus X1? Good. All right, I see a lot of double negatives there. Make them positive, good. What's 3 plus 4? 7. Over? 0. Negative 2 plus 2. Think like you're 2 distances away from 0, then you come back. See that? Okay. So we have 7 divided by 0. Notice the difference between that and 0 over 7. You see the difference? It flips. 7 divided by 0. That seems kind of funky, doesn't it? Right. If we translate division into words, this is saying how many groups of 0 fit into 7. Seems kind of weird, doesn't it? I don't know if you all remember this or not. This is what we call the undefined slope. Do you all remember that? So if you get something over 0, we write n is undefined. Because we can't divide by 0. Which one? Because there's a minus right there, so negative 3 times a negative 6. Let me see. Negative 3 times negative 6. There you go. There you go. So positive 18.
3 and 12, negative 12.
So you want to move the 12 over? Is that what you're saying? So this was originally negative 12x. So I should I add or subtract? Add 12x to both sides. Yep. So now we're just going to go through some questions to review what we've learned today. Okay? So number 1, I want you to write this on your whiteboards. I'll come around and check. Oh, let me hold this down for us. All right, true or false? The slope and rate of change have the same meaning. True or false? As long as you're on your board, true or false? T or F even if you want to. The board's up, let's check it out. Looks pretty good. Remember, slope and rate of change do have the same meaning. Good job. Pull up our boards, let's see. See the formula.
Hey, hold it up.
Okay.
We want to use no, that's not a formula.
So a couple things, right? The formula should be y2 minus y1. And we should be putting m equal, guys, so we know what we're talking about. M equal.
Which one was it?
This is too dark.
Okay.
You don't want this on there.
Try another one.
Uh-uh.
So what letter, or what we call an alpha character, represents the slope of a line? What's that letter we use for slope?
Yeah, they fall out.
Put it on your board. Put it on your board. We'll check them.
Jesus, can you read that to me?
So n equals. To here. Minus x1.
Oh.
What's a negative over a negative? Positive, so we can simplify that, right? Yours looks good. Give yourself a tally if we are right. Good, good. Ooh. What is this? What's that doing there? What does that mean? Oh yeah, there you go. Yeah, no problem. Oh, what does this mean? It's not neat. There. Oh, not a negative.
It doesn't matter because it's not.
But still, what does this mean?
It's undefined.
There you go. There you go. You get it? Doing awesome. Pull up your boards. Okay. Did we all get 0? Now let's talk about it. So we know positive slopes are increasing lines, right? Negative slopes are decreasing lines. So a slope of 0, what do you think that stays the same? The rate of change is constant, means it stays the same. Horizontal, the rate doesn't change. Remember, vertical is undefined. You should have a horizontal line. Okay, guys, good job. So right now, Mrs. Taylor is passing out your homework for tonight.